Alright, so this is going to be our next notes in geometry, and it's going to be on something called a translation. And you've seen these, and it's just moving all the points of a shape or a line a certain equal distance. And it can be done lots of different ways. The one we're going to look at today is moving them all the same direction. In a translation, if we just want to define it, a transformation is one that just moves a shape. A translation is a type of transformation that moves all points the same distance and direction. Okay, so that's really what defines what we're doing today. We're taking the points on any shape and we're moving them the distance and the same direction. Okay, one way to do that is with something called a translation vector, and that's really a function or a length of something or a vector that helps tell you how far you need to move something. And we have one right down here. We call this W. This is a translation vector, and it's this far, and it'll tell you what general direction to move them in and then how far. And you can tell how far just by the length of the vector itself. So if we measured this, we would say it's about 1.5 inches. So what we do, general procedure, is once you know what the vector is, you draw lines from each point parallel to the vector, and then you measure the vector and locate the new points and connect the points. Okay, so you might want to just draw some lines. There's a couple ways to do this. You could make it exact, but you could just draw. You want to make sure these are parallel. So we want to draw the line, and then we want to draw another line. We'll make this plenty long enough here, just to be sure. If you make the line bigger, it doesn't matter. Same one here, and then the same one here. Okay. And then we just want to move these points this distance. So we said it's 1.5 inches. So we'll just take it, we'll figure out where the 1.5 inches is, and then we'll just label that line. It's right there. That's going to be C prime, the new point. And then this one's going to be 1.5 inches. This one's going to be right about there. That's called A prime. And then B, same distance, 1.5 inches. Put it right about there. And that's B prime. And then we can just take a thing and a roller, not a thing, a roller. And then we can just connect these. These aren't as exact, but this is a possibility you could use. In some ways this depends on how accurate you're using your roller and such. You see that right there. So we moved that. We redraw this shape using a vector. So that's one example. And that's one way you can do it with a translation vector. But also there's some different ways. One is through something called vector notation, and you really tell what is the x and y coordinate of that total vector, and then you plug it into the points you already have, and you can figure out where that new point would be without having to draw lines. Okay, so now we're talking about a coordinate plane. It's something that has the plane labeled, negatives and positives, y's and x's, and we can figure out where that new point would be because of that. And vector notation, we have an A and a B, and it's just like you would think. X is along the horizontal, so A would be referring to the change in the x, and then B would be the change in the vertical or the change in the y. So vector notation. So if we continue to look at an example here, so if an example would be here, I showed you, so A and B, so A would be the x, it'd be 2, we'd move it 2 on the x, and then the B would be the y, we'd move it 5 on the y. And then what we do is we take this new vector coordinates and we add them to our original coordinates that we started with the shape, and I'll show you an example in a minute. But a good way to look at this is you have these original points, these are the originals, and then the vector coordinates are A and B, or they could be numbers, we could put them in there. So we'd have x plus A, that gives us a new coordinate, and then y plus B, that gives us the other new coordinate. So let's look at an example of this. So let's say we start off with this point here, point P, and that point is -2, 3. So, and then we want to translate it. We're just going to be translated by the vector 7, 4. So we're just going to take these original points, negative 2 and 3, and we're going to add 7 to the x and 4 to the y. And it gives us a new negative 2 plus 7 gives us 5. And then the y is 3 plus 4 is 7. So p prime, the new spot, would be 5, 7. And then we could see, we started off, this is p prime, started off at negative 2, 3. But then we moved it to 5, 7. 1, 2, 3, 4, 5, and up 7. So that's an example of using the vector coordinates as well. Okay, so if we keep going, let's look at an example of this as well on some graph paper here, and then we'll move it as well. So this says translate the following image along the given vector. So if we have this original shape here, EFG, and E is at point negative 7, negative 1, F is at point negative 4, negative 4, and G is negative 3, 1. So that's our original 3 points. If we looked at it, it would be right down here. We're going to move it in a minute. And then it says our vector coordinates is 2 and 5. So we're going to change the x by 2 and the y by 5. So it's really going to be, if we look at this example, x and the y, whatever they are originally, there's going to be differences, 3 points. We're just going to add 2 to the x and 5 to the y. So if we do that to E, we're then going to change E prime is going to be equal to negative 7, or E is equal to negative 7 and 1. So then we add the 2 to the negative 7. It's going to give us negative 5. And then to the y, negative 1, we add 5. It's going to give us 4. So E prime is going to be this right here. And then F becomes F prime when we add 2 and 5. And that gives us, starts at negative 4 and negative 4. And we get negative 2, 1. That's our F prime. And then G is negative 3, negative 1. And new points are going to be negative 1 and 4. Because we're just taking this vector and we're adding it to each one of the x's and the y's. Okay? And we get these new prime locations. So G prime, F prime, and E prime. So then if we just put these in here, so we'll start with E prime, negative 5, 4. So we'd go 1, 2, 3, 4, 5. And then we would go up 4. 1, 2, 3, 4. So 1, 2, 3, 4, 5. We're going to go right up to here. That is E prime. And then we have F prime, negative 2, right there, negative 2. And then we're going to go up 1. It's going to be right there. That's F prime. Just going to put that in there. And then we have G is going to be negative 1 and 4. 1, 2, 3, 4. And then we would just connect them. You know, we could use a ruler. I'm just going to do it really quick. And there we have this translation right here. We just move this direction, 2 on the x, 5 on the y. Okay. The x is like this way. So it moved from this E to this E over 2, and then it moved up 5, right? So this one, we went 1, 2, 3, 4, 5, right? So that's how you do those. That's an example of that. And one last thing we have to look at is, so how do we should also be able to describe these if we see them. So if we know we have a point like A, that's our original point, and then A prime, how do we describe these, the change, and figure out what the vector coordinate is? Okay, so we would do that an easy way, and some of these you might think, I could probably do this in my head, but maybe not. But it's good to know the longhand version of it, and if it bothers you or it takes too long, at least do it in your homework, and then if you think you can do it in your head, still wait until the test is over. Then once the test is over and you've shown you can do it, then do it in your head, all you want. So, but x, y, so we know this is our original coordinates, and then we know if we add a and b to each one, we will get the prime coordinate, the new one. So we know the coordinates for A, the original are 2 and 2, and we know the prime for A are -3 and -2. That's their new coordinates. And we could probably almost eyeball it and see how many it moves, but we'll wait. But we can use this idea that we know this is one part of it, and this is another part of it. So if we take this x plus A, and we make it, we see, well, how much is that change? So we can just say, we can solve for it. So we can say the x from here is 2 plus A, we're going to figure out what A is, and that equals, in the end, it's going to be -3. Then we do the math, -2, then A is going to be -5. That's our first answer. That's really the x part of the translation vector. Then we do the y portion of it, or B, I guess you can call it that. And you see here, we just take this y plus B, we plug it in, we know that y is equal to 2, so 2 plus B equals, and in the end it's going to be -2, so we minus 2 from both, and in the end we get B equals -4. So then our translation vector is -5, -4. And that's kind of the notes for this. I don't think it's too hard, and I think you'll be able to do that homework when we get in class. And let me know if you have any questions, and keep